Okay, so this first video for properties of real numbers is going to be pretty quick. We've got all these vocabulary words describing different sets of real numbers. We've got real numbers, which is the big one, rational numbers, irrational numbers, integers, whole numbers, and natural numbers. So we've got this visualization that I'm going to give you, almost like a flow chart sort of thing. So start by drawing just a big rectangle here. Okay, so this whole big thing here represents the real numbers. Okay, so real numbers, that's basically everything that we know so far. Every number that you have ever heard of falls under the category of real numbers. Okay, so then within that, I want you to draw just a slightly smaller rectangle. Okay, so inside the category of real numbers, there are two different types of real numbers. There are rational numbers and irrational numbers. Okay, so divide here. So these will be the irrationals over here. And then these will be the rationals. Now the rationals have many more categories within that category, so we're going to leave, that's the only reason we have more space. This doesn't mean there are more rational numbers, there are actually more irrational numbers, but there are no further subcategories here, and there are more subcategories here. So remember, real numbers, anything at all. Rational numbers, if you remember from your vocabulary, it's anything that can be written as a fraction. So like 2 over 3, or like negative 7 over 8, or something like that. And then irrational numbers, you've got things like pi, or the square root of 2, or something like that. Basically anything that can't be written as numerator over denominator. Okay, so then inside of the rational numbers, we've got yet another set. Okay, so I'm going to start drawing circles here. Okay, so the next subcategory inside the rational numbers is the integers. And integers, again, if you remember, are defined as positive or negative whole numbers. So like 2 or negative 4. And integers are also rational numbers, because think of like 2, for example, you could write it as 2 over 1, and that technically makes it a fraction. Inside the integers, we can get a little more specific. And we can say whole numbers. Okay, so whole numbers are basically 0, 1, 2, 3, 4, 5, 6, 7. So integers, but none of the negative ones. So integers could be positive or negative. Whole numbers do not include the negatives. And then they've got this category, final category, that they call natural numbers. Natural numbers are almost exactly the same as whole numbers, except they don't include 0. So natural numbers are just like 1, 2, 3, 4, 5, 6, 7. Whole numbers include the 0. Integers include the negatives. Rationals include any other fractions. So that's a pretty big category. And then irrational numbers are anything that can't be written as a fraction. So the examples I gave were like uneven square roots, or like pi, or other things like that. Okay, so this kind of shows how the categories fall within the other categories. Okay, example, we're going to look at a handful of numbers here and then categorize them. So you write any and all categories that they all fit into. So here's a hint. Every single one of them is a real number. So you're always going to give the answer of real number. So square root of 6. Square root of 6, it's definitely real, because like I said, they're all going to be. And then you go into the next category. Is it rational or is it irrational? So can it be written as a fraction or can it not? And it can't. Square root of 6 is some crazy decimal value. We can't write it as a fraction, and so it's irrational. So looking at this visualization, if it's irrational, it's not going to be any of these. So once you say it's irrational, you're done. Okay, next, the number 5. It is real. We know that. Like I said, they're all real. Is it rational or irrational? Well, it can be written as a fraction. You can write it as 5 over 1, so it's rational. And then we'll kind of go down the line. Is it an integer? Yeah. The denominator is just 1, so yeah, it's an integer. Is it a whole number? Meaning, is it non-negative? And yes, it's positive, so it's a whole number. And is it a natural number? Meaning, is it a positive number that's not 0? And yes, it's definitely a positive number that's not 0. Okay, next, on to negative 2/3. Again, every single one of these numbers is real. Is it rational or irrational? Can it be written as a fraction or can it not? Well, it's clearly written as a fraction, so it's rational. And then with this one, that's where we stop, because it's not an integer. Integers are positive or negative whole numbers, and it's not a whole number, it's a fraction of a whole number, so it's just real and rational. Negative square root of 9. We know it's a real number. Now this one is intentionally meant to be a little bit tricky, because you see a square root and you might think it's irrational, but the square root of 9 actually comes out evenly. So remember, this is actually the same as negative 3. So let's go from there. It's rational. So it can be written as a fraction. You can write it as negative 3/1. It is an integer. Remember, integers are positive or negative whole numbers. It is not a whole number because it's negative. So integers is the smallest subcategory that it falls into. All right, so that is your summary of real numbers. So the second half of section 1-2 is going to deal with properties of real numbers, but more importantly, how we can use those to start to simplify up numerical and algebraic expressions. Okay, so let's fill out this chart and get to know what these properties mean. So there are a handful of properties that apply to both addition and multiplication. So I'm sure many of these are going to be familiar. The commutative property is the property that tells you that you can go in either order, and that works for addition and for multiplication. So this says that if you add a plus b, it's exactly the same as adding b plus a. And so you could easily plug in any numbers that you want and make that make sense to you. So multiplication means a times b is equal to b times a. So addition and multiplication, you can go in any order that you want. Associative is the grouping property. It tells you if you've got 3 things, you can group them together however you want and start there. So say you're adding a plus b plus c. You could group a plus b together, add that first, then add c. Or if you want, you could group the b plus c together, add that first, then add the a. So it's similar to the commutative property, but it deals with how to group 3 things together. So multiplication, basically the same. You can multiply the a times the b together first, then times c, or you can multiply a times what you get from b times c. Okay, those two I'm sure you've heard of. Identity and inverse might be new. The identity, so think of like something's identity. It's, a person, it's themselves or something like that. So for an identity, you want to know what you can add to make the number stay as itself. So say you have a number and you want it to stay itself. You don't want it to change. So what do you add? You add 0. And if you add 0 to something, its identity does not change. So with multiplication, if you start with a number, what do you multiply? You multiply by 1 to make sure that it stays the same, keeps its identity. Inverse property also might be new. Inverse, you actually want to make your way back to this identity. Okay, so say you start with a. If you want to make your way back to 0, what you add is the negative version of that number. So a's inverse in terms of addition would be negative a. So think of like 4 plus negative 4. If you add them together, you get back to the identity. And then multiplication is a little bit more complicated. If you start with a and you want to end with 1, what you do is you multiply by 1 over a. So we call that the inverse of multiplication, or the multiplicative inverse. So think like 3 and 1/3. Those are inverses of each other in terms of multiplication. Okay, and then closure. Closure property is a little bit interesting. It says that real numbers are closed under addition. What that means is that if you add 2 real numbers together, the number that you get is still a real number. And so we also say that multiplication is closed, which means if you multiply two real numbers together, what you get is also a real number. Okay, very last property, this one I'm sure is familiar as well. I'm going to kind of write this in the middle because this counts as both addition and multiplication. This says if you've got a number, and then in parentheses you have b plus c, so like this is implied multiplication. You're multiplying a times the quantity b plus c. The distributive property says that you can multiply the a times the b, then the addition, and then multiply the a times the c. So we say that this is distributing the a across the multiplication. Okay, so those are your properties. Now, first we're going to talk about how to recognize them, and then we're going to talk about how to use them. Okay, so this one. Name this property. This says negative 8 plus 8 plus 15 is the same as 0 plus 15. So if you look at the difference between the left and right side, the difference is this side has negative 8 plus 8, and this side has 0. So what property tells you that negative 8 plus 8 gives you 0? So let's flip back and take a look. Well, it's addition, so we know we're in this column. It's not this, not this. This has a 0, but it's not quite right. This is the property that we're looking at. It tells you that negative 8 and positive 8 add together to give you 0. So this is demonstrating the inverse property. Okay, example 3 is also applying these properties. It asks for the additive and the multiplicative inverse for 7. So the additive inverse, you're basically trying to figure out, all right, what would I add to negative 7 in order to end up with 0? And so the additive inverse is actually just the opposite sign. So negative 7, the additive inverse would be positive 7. So think about that. If you add them together, you're going to get 0. They essentially cancel each other out. And then the multiplicative inverse is something that we call the reciprocal, and I think you guys have heard of that before. You basically just flip it. So this fraction is like negative 7 over 1, so you flip it to negative 1 over 7. So if you multiply these together, you would get 1. Okay, next, we got kind of a story problem here. So it says Audrey went to a post office, bought 8 45-cent stamps and 8 32-cent stamps. What was the total amount of money Audrey spent on stamps? So she bought 8 45-cent stamps, and, which means you're adding if you're trying to figure out the total cost, and 8 32-cent stamps. Okay, so this is actually demonstrating the distributive property. We don't have to write that, but it is. So see how there's an 8 in both of these spots? So you've got two options. You can either do this multiplication, and add them together, or since she bought 8 of each, it's the same to write it like this. So this is actually almost like the opposite of distributing. So if we keep the 8 on the outside and then add these two together, so if you add 45 cents plus 32 cents, what you get is 77 cents. And then remember, like I've talked about, these are skills I want you to be able to have without a calculator, so you should be able to multiply that by hand. So we get 56, carry the 5, we get 56 again, 61. So since this has 2 decimal places, we should move our answer 2 decimal places. So this is $6.16. You could, of course, always check it with your calculator, but I want you to be able to do that by hand. All right, now this is what I was talking about, being able to apply the properties that we just learned in order to do something useful with algebraic expressions. So simplify the following expressions. What we're going to do here, first thing we've got is the distributive property. Okay, so see how there's a 4 on the outside here. We're going to distribute. So 4 times 3a, that gives us 12a. And then distribute the 4 to the negative b. So we get negative 4b. Then we're going to distribute this positive 2. So 2 times b just gives us 2b. And then 2 times 3a, the 2 times 3 gives us 6, and then there's still an a attached. Okay, so that was the distributive property. Next, we can use the commutative property to kind of rearrange and combine up like terms. So even though these two aren't right next to each other, the commutative property tells us we can still add them together. So 12a plus 6a, we just add the numbers together. 12 and 6 is 18a. And then these two we can add together. So negative 4b and positive 2b gives us a negative 2b. So that would be a simplified version of what we started off with here. All right, let's do one more, little more complicated. These ones have some fractions. So here I'm going to distribute the 1/3. So 1/3 times 5x. 1/3 times 5 is just 5/3. It's not pleasant, but that's what it is. And then plus, same thing here, 1/3 times 8y. We get 8/3 times y. And then here we distribute the 1/4. So 1/4 times 6 is 6/4, but 6/4 can actually reduce down to 3/2. And then distribute here, 1/4 times negative 2. Negative 2/4 also reduces down to negative 1/2. Okay, so just like the one up above, what we are going to do is combine like terms. So these two are both x's. Now here's a little fun with fractions review. These do not have the same denominator, but we can make them have the same denominator. So this should have a denominator of 6 in order to be common. So multiply this one by 2/2, and we end up with 10/6. Multiply this one by 3/3, and we'll end up with 9/6. And then we combine those up. So 10/6 plus 9/6 is 19/6 in front of the x. And then same thing, these actually should have the same denominator, a denominator of 6. So multiply this by 2/2, and you get 16/6. Multiply this by 3/3, and we get 3/6. So 16/6 minus 3/6 gives us 13/6. Okay, so again, not the most pleasant of numbers, but what are you going to do? Okay, and a very quick extension. We talked about closure. So we want to see if any of these are closed. So the set of integers is closed under multiplication. So if you multiply two integers together, are you always going to get another integer? And the answer there is yes. Because think about like -5 times +3. The answer is still an integer. The counter examples are going to be the ones that are easy to see. Set of whole numbers is closed under subtraction. That is not. If you subtract one whole number from another, you're not always going to get a whole number. Think if you do like 2 minus 5. That gives you -3. -3 is not a whole number. Next, whole numbers are closed under division. No, they're not. Picture 2 divided by 3. That's no longer a whole number. And finally, the set of irrational numbers is closed under multiplication. That is actually, let me see. No, that is also false. That is false. So here's an example. Say you had like the square root of, let's see, square root of 8, which is irrational, times the square root of 2. You'd get the square root of 16, but that's actually a rational number because that's 4. Okay, so that is the end of 1.2.